Good morning, friends. I am here again for the aircraft systems, my course. Today I am in lecture number 5. The topic for the today's lecture is avionics systems and subsystem. Okay, so as you know, my name is Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As you know that I have started this aircraft systems, and today this is my 5th class. Before this class, I have, my lecture number 1, I have discussed about the introduction to aircraft systems. Then lecture number 2, I have discussed about the systems and subsystems. Lecture number 3, airframe systems or the structural system. And lecture number 4, I have discussed about the vehicle system, which consists of the flight control system. Then it consists of the propulsion system, fuel system, and hydraulic system. This I have discussed. Today I am in the third vertical. In third vertical, we have the avionics system and their subsystem. This I will be going to discuss today. The content for the today is revision of my previous classes, avionics system, which consists of the navigation system, communication system, display system, then next class topics, and then avionics system. So here we have the revision, and in this revision we have done with the introduction of airframe, structural system, vehicle systems in our previous classes. This you can see the airframe and structural system, then vehicle system. In airframe, we have seen the wing, we have seen the empennage, we have seen the fuselage system. In vehicle system, we have seen the fuel system, propulsion system, flight control system, and the hydraulic system. We have seen this all things in my previous classes. If you see the structural system, we have here the wing and their parts, which I have already covered in my previous classes. In this, another is the empennage, which consists of the horizontal tail and the vertical stabilizer. It is also called the horizontal stabilizers. And here we have rudder, here we have the elevator, and here you can see the rear spar, the front spar, hinged shrouds, leading edge, trailing edge, foot spar. There's so many things. And if you see the fuselage, we have here the forward section up to here, and it is then we have the mid section, then aft section, and this is called after body. In after body, this horizontal tail and vertical tails are fixed. If you see this frame, here we have the frame, we have the longerons, we have the stringers. These are the parts which are fixed in this fuselage. Here we have the keelson. It is the strongest part of the aircraft, and here your wing spar is fixed in that. I have also discussed about this vehicle system. It consists of the flight control system, and here we have the 3 primary controls which I have discussed. Then we have the reciprocating engine here, and then I am going to discuss today avionics system. And here we can see the avionics system. We have the navigation, control, display system, and communication system, which is shown here. So if you talk about the avionics system, so we have to see about the navigation. So navigation means how you will locate your aircraft, how you will reach to a destination, because it is not a vehicle that you can go by road and you can see villages and all. In aircraft, you can't see like this, and a lot of clouds, so many other types of environmental are there. So in navigation, we have to see the altitude of the aircraft, how much height, how much speed your aircraft is going, what is the heading, the direction of your aircraft, heading earth related coordinates, because you know that the aircraft is facing a lot of challenges, and one of the challenges is relativity, because the pilot is in the body frame and the ATC is in the earth frame, and the engineer is in the laboratory frame, and it is called the stability frame. So which frame we have to follow? You know that we all have to follow the pilot, where pilot is sitting. So ATC people have to talk in the manner of the pilot's perspective, and the engineer also has to think about the pilot's perspective. So we all have to operate in the one zone that is called the body axis system. But you know that Newton's laws are not applicable on the body axis system. They are always acting on the inertial reference frame, that is the earth axis system. So in olden days, there used to be a lot of accidents due to the miscommunication and misjudgment of the aircraft, and they used to do in this way, and a lot of accidents have happened in the previous time. I have shown here some earth related coordinates, that is called the earth axis system, position and the flight legs. These all things we have to understand. I will start with this here. If you see here, that is the magnetic deviation west. If you see, this is the true north and this is the magnetic north. There is some difference between the true north and the magnetic north. Bearing magnetic, and this is the heading. Okay, so this is the bearing true and this is the magnetic deviation. This much deviation is expected by the magnetic compass. If you see this one, here we have the drift angle. This is the heading, and it is a wind. If it is in this direction, your aircraft will not go in this, but it will go in this direction. So there is some drift of the aircraft which we have to tackle. We have to handle this type of situation. If you see this diagram, the first one, here aircraft present position is here. It is shown here, and then here is the magnetic bearing. It is shown here. So here is the magnetic bearing. This is the magnetic north, and this is the true north. Both are not the same. So if your aircraft is heading like this, so your track will be drifting. This much angle your aircraft is drift due to the wind direction. If you see the altitude of this aircraft is here. This is the VZ, barometric altitude, then radar altitude, indicated airspeed or Mach number. All these parameters has to be verified, and this has to make sure that aircraft is able to access this required thing. Wind speed vector, wind speed direction. This is the wind direction. This is the heading. If the direction is this, your aircraft will be in this direction, not in this direction. Okay. So this much waypoint position, latitude and the longitude, you have to reach in this, and you have to find out what is the latitude and longitude of the aircraft. These all things are called the navigation. Aircraft has to reach to the given longitude and the latitude, but if there is a wind direction, there is a gust, there is a abnormal atmospheric condition, your aircraft will likely to drift from its original position. It may go left or right, anywhere, as per the wind condition, wind direction, wind speed. So all things we have to see, and this comes under the part of the navigation system. Now, aircraft navigation system in use today. What are the navigation systems are used as of now? So first one is the ground-based navigation aids. What are the equipments used on the ground for navigation? So this is the VOR, DME beacon, that is the very high frequency omni range distance measuring equipment beacon, alongside the NDBs. They are also the navigation directional beacon. Okay, so they are made on the runways, on the airports. From there, some signals are transmitted. These signals are received by the aircraft, and accordingly, the aircraft has got the receiver, and it will receive the signal, and it will give the direction of your aircraft. Next is air data and inertial navigation. So these are used by inertial sensors like your air data sensors, your pitot tube, and artificial horizon. All are air operated systems. So they will give this. They will use this type of system. Next is the global navigation satellite system. This is called the GPS systems. So in this we have the GPS satellites. Then we have GNSS, 12 channels, receivers, and the GLONASS. So what is this GNSS? It is a global navigation satellite system. It is called GNSS. GPS is global positioning system. It is used 24 satellites are there, and particular location they will give the signals. GLONASS is a Russian system. GLONASS, it is a global Naya navigation, Noya Sputnikova Systemata, or global navigation satellite system. It is called the GLONASS. So these are the few systems which are used. So we can divide this thing into three groups. One is the ground based, that is a radio navigation system, that is VOR, DMI, and DB, which are fitted on the airport. Air data and inertial navigations are fitted on the aircraft. If you talk about the air inertial navigation, they are this gyroscopes, accelerometers, and all. And air data means it is a pitot tube, your other air operated equipments. These are used on the aircraft. It is also shown how these things are global based, ground based navigation system GNSS, how these things are operating. So here is the waypoint 1, waypoint 2, and waypoint 3. Here VOR1, DMI1, VOR2, DMI2, VOR3, DMI2. So here NDB is there, it will give signal to the aircraft, and like this different locations we have this, and from here aircraft is receiving the signal, and it will operate, and it will find out that which position aircraft has crossed. So like this, every some 100 kilometers or something, this VOR and DMEs are located, and everyone has got the own frequency, and aircraft has got the receiver. It will receive, and it will come to know that it has reached the position 1, it has reached to the position 2, and it has reached to the position 3. Air data inertial based navigation system, it is called INS systems. So in this, and this is the radio system here, and here due to the gyros and accelerometer, it is latitude 1, longitude 1, waypoint 2, and waypoint 3. Both are operated at the same time, this one and this one, and mostly they will go near by near, and if any drifting or any one system is failed, another system will start operating, and they are parallelly operating both the systems. If you see here that global navigation satellite system, we have the GPS plus GLONASS constellations and waypoint 1, waypoint 2. So here these satellites are giving the signal, and accordingly it will same way 3 positions are matched. Okay, so in this way we can get our navigation by the satellite system also. Now if we talk about the avionics system, we have the flight display, we have the first generation display, we have the blind flying technique, we have the second generation display, and we have the next generation displays. So display, if you see that the history of the display, so from the 1970 revolution, we have seen that here cathode rays, it is called the CRT, like our TVs and all. Then active matrix LCD, AM LCD. Then here 3 crew members. Here electronic centralized aircraft monitor. And here we have the engine indicating and the crew alerting system. So if there is a problem in engines, these systems will operate. So most of these systems have started in 1970, but nowadays we have very advanced 2 crew members, and here if you have 3 crew members, they will use this CRT, and if it is 2 crew members, they can use active matrix LCD AMLCD system. Okay. If you see the display, flight display systems, initially it was used electromagnetic era from 1918s, 1929s to 1970. This era was there. First electric, then magnetic, then electromagnetic. Okay. Now 70s, 1980s, 99 and early 2000, this was electro-optics era up to few years back, and now it is coming to next generation flight display. So if you see the modern flight cockpit, very, very advanced, and you will enjoy to see the cockpit itself. It has reduced tremendous amount of hard work of the pilot. It can concentrate on the safety of the aircraft. So these all systems are used not only for showcasing, but to improve the safety of the aircraft. A tremendous amount of safety is improved. Nowadays, the failure rate of the aircrafts are very, very minimum. In lakhs of flight, there may be one error. Not that is also accident, maybe some failure. But that is also, the engineers, aeronautical engineers are trying to solve that problem also. So it is the redundancy of this aircraft as of now is 10 to the power 6. Means out of 10 lakh of flight, there may be one failure of the aircraft. That much it is one of the most safest flight on the earth. So you can see the first generation initial, you might have seen in old aircrafts like this 1918 first primary display, PFD, primary flight display. It is shown here. Contains every instruments like a compass. In this, so many are there: altimeter and pressure datum set, then airspeed indicator, time indicator, rate of climb indicator, engine RPM, inclinometer, all things. It was like this. Primary flight display by Smith and Sons. Now it is Honeywell. So Honeywell, it is now name is given. Previously its name was the Smith and Son. They have manufactured in 1918. If you see the blind flying technique, so Lieutenant James, this is the Lieutenant James Doolittle gyroscopic instrument plus radio navigation aids, uses Coleman precision altimeter, Sperry gyroscopic artificial horizon. These were used. If you see here, artificial horizon aligned to real horizon. Just you can see how it is visible. Then model aircraft bank, you can see here, horizon fixed to the aircraft, outside looking in. Sperry artificial horizon. These all equipments were used, and this is called the blind avionics display. Is first very, very old, maybe more than 100 years old. This system was developed. Now, first generation, if you see your Boeing 737 and all. So here you have the engine instruments here. You have the autopilot control is here. Basic T-test of the primary flight instrument. Every instrument has to be tested before starting the engine. You see so many thousands of indicators. So how the pilot will be able to manage? So one flight engineer has to sit here. That flight engineer will monitor this all type of things, and the front is monitored by the two pilot. Boeing C-737, this aircraft is looking like Boeing 737 a cockpit. Okay, and here the flight engineer has to sit, and the pilot will say what RPM they want. Engineer will set, and he will operate, he or she will operate all the necessary controls of the engine. Slowly it is come to the second generation, and here you see some 6 spikes are here, all altimeter, ROCI and all, and this you can see. Okay, this type of engine indicating and crew alerting, EICAS, EADI electronic attitude and director indicator, EHSI, electronic horizon and situation indicator. These type of equipments are used. Here is an airspeed indicator, altimeter, standard altimeter, all are INS, inertial navigation system, altitude indicator, EADI, EHSI, horizontal situation, system display, engine display, all the things are here, but it is now somewhat better than the first generation. Now it is the second generation and it is now very good display. You can see here that autopilot announcement, enunciators, select height, flight director here, flight director is here, vertical speed indicator is here, barrow height, vertical tape indicator, Mach number indicator 0.533, heading scale here, altitude ball here, airspeed indicator and selected speed. Here these all things are fitted here. This you see electronic centralized aircraft monitor display, integrated standby instrument, navigation display, all the things are fixed and it is placed in the such way. So now how much improvement you are getting in your aircraft. Avionics system display, second generation, ECAM Airbus 380 to 2007. Here we have the 6 displays, 2 PFD primary displays, 2 ND navigational displays, 2 ECAM displays. Control and handling similar previous aircrafts. Now EICAS Boeing 787, CTOM AMLD, just you can see here, single PFD, 18 replaceable units, 2 head-up display and electronic centralized aircraft monitor. These things you can see here that there is difference between a Airbus and the Boeing 7. These are the latest aircraft. Okay, so here the difference is for both. You have the 2 different displays. Here we have 1 display. It is a CTOM AMLD. Single PFD is there. 18 replaceable units, 2 head-up display. Head-up display, just you can see, these are the head-up display. All the equipments pilot can see in front of that. As and when pilot need not to see below. All this required data are available in front of the pilot on the cockpit glass. So that much it is Airbus is using, the Boeing 787 is using this second generation display system. Now it is next generation, the modern aircrafts which are this you can see here. If you talk about this head-up display, so what is the head-up display and why it is required? You know that the olden days, I have shown you, if like this Boeing 737, if like this is there and pilot will not be able to sit front, pilot will be observing all these instruments, all the things. So what happened? Pilot should not see below. All this equipment should be visible here, this side and this side. In the glass itself, one small glass. So both pilot need not to see below this. Every data will be shown here in a glass. So they can take the decision and they can monitor the things by observing all the things outside also, and inside the things they can monitor. That is why head-up displays are introduced. Nowadays, not only head-up display, helmet-mounted display is also HMD, helmet-mounted. In fighter pilots, in their helmet glass, all the parameters, required parameters, not all, required parameters as the pilot want, what the parameter he want to see, he or she want to see, those all the parameters will be visible on the screen or the glass of the helmet. That type of technology also has been come, especially for the fighter aircraft. However, for the passenger aircrafts like Boeing has already started using in this, you can see In this Airbus, it is not there. But if you see Boeing 787, this head-up displays are there. In this, you can see all the parameters here, and pilot need not to see below. So nice, so compact. All the parameters are visible, and very cool atmosphere, and everything. You can see the radar here. Radar is also visible, and all these PFDs, 2 PFDs are here. In this, all the major flight requirement pilots can see very well. So that was the intention of this aircraft, to give a very good knowledge of this avionics system, and this avionics has made the aircraft operation very safe. So as of now, we can see that the engine indicating and crew alerting system, very important system. So in this, what happened? Engine indicating and crew alerting system. This is the system. If anything happen, abnormal to the aircraft, the alert will come. Alert sound will come to the cockpit of the aircraft. So what is the meaning of engine alert? Engine is very important. So if any abnormal, assume your oil is heated up, the engine lubrication oil is heated up, the performance of the engine will go down. Your bearings may get jammed. So how you come to know? There is a sensors. Those sensors will give the signal that the oil is overheated. Pilot will take the necessary precautions and try to land at the earliest. Okay, same way, if it is not happening, this aircraft, and pilot try to oversee, this thing will happen. Okay, so these all things has to be taken into consideration. So now these are the next generation. These are the next generation avionics system, and in this, what is the aim? They are the very modern cockpits, and you can see very few items are there. In this, what is the aim? Aim is to crew centric, means it is a pilot centric. How pilot want, they can see the cockpit. Simple and intuitive human machine interface. Simple and intuitive human machine interface. Then one display for a cockpit interface solution by Thales. Popping window HUD, touch screen interface, direct voice command. This will come by 2030. So these new things will be available. That is the popping window head-up display. Head-up display will come out as and when pilot want. Then touch screen interface. He will touch and the required thing will come out. Direct voice command. Direct voice command will be there. This company is making, that is the Thales company, one display for a cockpit interactive solution, and all the things will be there in one display only. So what are the displays? Cultural features, city, wide angle color head-up display here, wide angle, anywhere it can see. Pathway in the sky, This you can see here. Then EFVS, TAWS, synthetic vision image here. Single contiguous large area wrap around instrument panel. Touch screen here. PFD, ND, ECM, FM apps, all type of apps will be here, and your screen will be visible like this. So this type of systems will also be used, and very soon, I think it is given by 2030, most of the modern aircraft, especially the passenger aircraft and also the fighter aircrafts, will be equipped like this. You can see the control stick. The control stick is here, very, very small, so beautiful. Okay, so it is just a concept image, and in future you are going to see like this cockpit, and it will be very useful in the future. So this we can see very shortly. So in the next class, I will be taking the mission system. In mission system, we will see the sensors, mission computing, weapon system, and others. When I talk about the mission system, the aircrafts are made for a different types of mission. Those missions are operated by the help of the sensors. There are some computers, weapon systems like missile guided, all the bombs, your missiles, and all other radars, other things will come under the others. And how these things are operated. Some of the aircrafts like helicopters are operated with some emergency like medical emergency or flood relief or the fire relief. Those type of equipments and sensors are also fitted on the aircraft as and when required. As per the design mission of the aircraft, those equipments are boarded on board the aircraft, and in this way the aircraft can be used for the mission requirement. These all things will be covered in my next class, and hope you have understood well, and we will be going for the next. These are the references which I am using: Moir I and Seabridge A, aircraft systems, mechanical, electrical, avionics systems, professional engineering publications, Limited, London, and Bury St. Edmunds, UK, ISBN 1860582893 Another book is Moir I and Seabridge A, Design and Development of Aircraft Systems and Introduction, AIA Education Series. So these are the books which I am referring, and from there I am preparing this your lecture. Thank you very much. Okay, I am just coming for this, and I will try to this is my email. So if any questions, you are welcome to ask in this mail. Thank you very much for this, and please be tuned for my next class, which is the mission system. In that, I will discuss what type of mission your aircraft is taking and how you can capture the mission. Okay, so in this way, I am ending my session here, and hope you have learned, and in future also you will be learning. Thank you very much for this.
Like, share and subscribe. Hit the bell icon for more updates.